Yes. Good morning, student. Today I am take here some important questions with you. Please note some questions which will help you to for the test on 25th. Yeah. Question is very simple. You can check 2 point charges 25 microcoulomb and 100 microcoulomb are placed 20 centimeter apart. At what point on the line joining the two charges the electric field intensity will be zero? So you know that if electric field intensity is zero, that means we can write EA is equal to EB. Is it right? And after that, you just write the follow of formula of EAB. Electric field at AP is just a point only given, right? Okay. E is the main electric field. Where K 25 by x square, you know 25 is the charge. Where micro and micro in both the side they cancel. Is it right? K again and 100 of another charge is 20 minus x. Why it is 20 minus x? Because 20 is the distance between the two, and in between, is it right? So one of the side is x and another side is what? 20 minus x. So overall I will get this, because 25 4 will cancel, and here the 4 square is 2, that's why I've written this. And after that the x value is nothing, it's an I think it is equal, it is 20x is equal to 20 by 3 from the 25 microcoulomb. That means when we take x distance, it will be from the 25 microcoulomb. Is it right? Solve it. If any problem, you can ask in the WhatsApp group. Number is there, right? Second question. Two charges 20 microcoulomb and minus 20 gram placed at 20 centimeter apart, A and B are respectively, which is given the diagram. Diagram is also given. You can check. Compute means find the electric field at C point, right? 20 centimeter away from both A and B. So you can check 20 centimeters is the distance. Here is also 20 centimeters is the distance. Is it right? Given to you. So when we find the answer, is it right? Just check it the answer here. So you can check the answer is here. E is equal to is the electric field. Answer is this. And E2 is this. But both are at some angles. Since the diagram given all sides are equal, so it is an equilateral triangle, so 60-degree will be there. Is it right? It's in 60-degree only. You can check the diagram. centimeter each. So look at here. This is the angle formed here, 60-degree. So that means components will be there. Is it right? So how to solve this components problem here? Is it right? You can check here. This is the resultant electric field. Here, since it is 60 degrees, so I think E1 60 and E2 60, and sign will be cancelled. You know, we have done already in the vector. So when we put the value of 60, cos 60, definitely you know, and you will get this result, and after that you will find this one. So the electric field we can find in this order also. Okay. Next question is, let me see here. A point charge Q is placed at O as shown in the figure, positive, negative, 0. If Q is a positive charge or a negative charge. This is the diagram. So you know well, VA minus VB, potential, you know, it's in scalar quantity. So if I'll take this diagram, A is very close, so VA is less. Is it right or not? It is very less, sorry, distance is very less, so VA value will be more. Where B distance is far away, so VB will be less. So overall, greater minus smaller value will give you the higher value. Higher means the positive value. So that's why VA minus VB will be positive. This is the answer. Is it right? Check, your answer is this. And in number 2, that is when the charge is negative, then VA will be less. For example, minus 10 and minus 5. Minus 10 is what, less than the minus 5. So you can check here, the answer is, that's why they have showing here, it is negative. Is it clear? And let's solve some board questions. Here is the board question. 2000, it is 2019. Know the pattern of the electric field lines when the point charge minus q is kept near the conducting plates. How it will be? So let me help you to draw this or to find the answer, right? I think it's very simple. You can take, this is a negative charge, right? This is suppose negative charge q, right? And there is a plate. How the charges? So if it is a plate, then charges will be distributed like this. If it is negative, then induced will be here, it is a plus by electrostatic induction process. You know well. Is it right? So this is your answer. Let's go with the next question. Write down the next question. That is, draw the equipotential surface due to the isolated point charges. Isolated point charges, single point charges, right? How the equipotential surface will look like? You know, equipotential surface, equipotential is a new word for you, but potential is not a new word for you, right? We can find this equipotential surface. You know, let me discuss here. A surface, right? There are different points are there. This is one point, suppose this is another point, and we know that due to the two different points and a charge is there somewhere else, so both the points will have the different potential because of the distance. Is it right? That means in a surface, different point has a different potential. But if all the points, has same potential, then such type of surface is known as equipotential surface. Is it right? So I think on that topics, our next video will be there. So get ready. The equipotential surface. Again, I will discuss. So what is your answer actually? Is it right? So your answer will be very simple. If there is a charge plus, then we know that field lines are outward in direction. Is it right? Like this. Then a surface here, this is the surface. It is spherical actually. Is it right? It will be what? Spherical. So I will come with the next topic, that is spherical shape. This is called equipotential surface. Okay. In another question, you can check here. You have to draw the equipotential surface due to electric field. We'll draw this one. And also, first let me answer this. Right? How to draw due to the what? So first of all, you have to draw the electric field lines. You know the electric field lines are like this. Is it right? These are electric field lines. You can see these are also electric field lines. And in this electric field lines, they are uniform. Is it right? This is uniform electric field. And in this uniform electric field, your equipotential surface is nothing, is a plane. Yes, a plane surface which make 90 degree with this electric field. Is it right? Yes. Here it's from 90 degree. Oh, the surface and the electric field. This is the answer of due to the electric field. Is it clear? Okay. Now another is draw the expression of electric field due to dipole moment at a point on its perpendicular bisector. Perpendicular bisector means you have to express the electric field at the equatorial line. Is it right? At the equatorial line. This is your answer. Is it clear? So you know we have already done this expression, that is electric field due to dipole at equatorial line. Check the answer. Is it right? Is there another question? Look at here. Two metallic spheres A and B kept in insulating stand are contact with each other. Is it right? A positive charge P is brought near the sphere A as shown in the figure. Two spheres are separated from each other and the rod P is removed. What will be the nature of the charge of the sphere A and B? Is it right? You can write the question first. Very important question. For that the answer will be, look at the answer here. In the answer you can check. Suppose this is a sphere A, right? And when you take a positive charge, then induction will be there and it will become negative and this will become positive. So the P, A and B will be negative and positive. Is it right? And after that when you remove them, it's separately removed. So A will separately negative and B will become positive. This is your B and this is your A. Very simple answer here from the board they always ask. But always keep it in mind how to give this answer. Thank you.